Hey everybody, this Algebra 2 lesson's on complex numbers, so let's go ahead and begin. The imaginary number I. Okay, so I is the square root of a negative number. It's imaginary, it's not real, but you can do some math with that if we go ahead and just let it be some imaginary number. You guys that are good at math, you want to take a fun math class in college, take a class called number theory or abstract math. They're classes you'll never use again in your life, but they're sure fun to deal with. And you guys that aren't good at math or struggle with math, I know you're sitting there thinking it's like proofs in geometry. Anyway, I loved it anyways, more than proofs. Okay, so whoops, this is I squared. I forgot to do something right here. So if I square both sides right here, if I equals the square root of -1, then by squaring both sides, it'll get rid of that radical, and I squared will equal -1. Can you see that? When I square that side and square that side, it gets rid of the radical. So I is the square root of a -1, and then I squared just equals -1. Okay, so the square root of r, square root of -r, sorry, as I change my fonts right here, is the same as you pull an I out and then it becomes a positive r inside the radical right here. Okay, so for example, if I had, I'm going to have to do that with every slide, I'm not going to. So the square root of -5 is just I root 5. Alrighty? So let's simplify some of these, you guys. Let's do the square root of -32. Okay, square root of -32, I'm going to pull the I out and make it the square root of +32. All right, you can see that right there. And just do what you've done before. Then simplify the 32. The prime factorization of 32 is 5 2's. And then 2 2's on the inside brings 1 2 on the outside. And another pair of 2's on the inside. These 2 2's brings another 2 on the outside. So you go ahead and multiply. I times 2 is 4i. And then you got the leftover 2 inside. So 4i root 2. Alrighty? Let me get rid of that there. Okay, so here I'm going to pull an I out and pull an I out of that and then break down that 24. Okay, so I get 5i root 6 minus I root 24. And then 6 is just 2 times 3, so that doesn't simplify. But 24 is 2 times 2 times 2 times 3. And then a pair of 2's come out right here. And then so I have, this becomes, this pair of 2's comes out with this I, becomes 2i. And they both have the same radical now, root 6. So it's 5i root 6 minus 2i root 6. And you can subtract them and get 3i root 6. So that's your answer right there. Okay, the answer is 3i root 6. Let's try some more, you guys. Okay, here. All right. Here I'm going to go ahead and pull the i's out first, you guys. So I have I root 3 and I root 27. And then now I can combine the i's and make it I times I, which is I squared. And then combine the square root of 3 and the square root of 27. Okay, now I squared, remember I squared back there was, let me go back to the slide that I had it still, right there that I fixed. I squared equals -1. So whenever you see I squared, you're going to substitute -1 in there, okay? So there's where I get -1 from that I squared right there. There's that 3, and then 27 is 3 times 3 times 3. Okay, so there's 4 3's. So 2 3's brings 1 3 out, 2 3's brings another one out. And then don't forget you have the -1 out there, so the answer is -9. That's my answer, is -9. Now a common mistake is people want to combine these inside the radical. Normally you can, but you can't do it when there's negatives. Because what happens with this is you get a negative times a negative inside of there, you get a positive, and you get the square root of 9. Well, the square root of 9 is not the same as the square root of -9. The blue stuff is the correct answer, not the red stuff, okay? So you got to pull the i's out first before you do anything, okay, to be safe. So do that with this one here, you guys. Go ahead and pause it, and then try to get the answer right there. Okay, when you unpause it, you pull the i's out, and you should get -5 root 15, okay? Because you get I squared again, which is -1. All right, so on this one here, okay, so 4 root -18 over root -12. Okay, I'm going to pull the i's out first. Okay, and then 18 is 2 times 3 times 3. 12 is 2 times 2 times 3. Okay, and then the i's can cancel. The 2's inside, the 3's inside can cancel. So I'm left with 4 root 3 over root 2. Okay, can't have the radical downstairs, so I'm going to multiply it by root 2 over root 2. There we go, we get 4 root 6 over 2. Okay, and then that's not the answer. Since these are both outies, they're not inside a radical right there, I can go ahead and divide this 2 into this 4 to get 2 root 6 is the final answer right there. Okay, let's try another one, okay? Okay, on this one, got to pull the I out first, all right? And then 32 is 2 times 2 times 2 times 2, 5 of them. And then two twos brings 2 pairs of them out. You get 4i root 2. All right, now I can't have this radical 2 downstairs, and I can't have the radical, the I, which is the square root of -1. So what I got to do is multiply top and bottom. I'm going to multiply it by 1, but my top and bottom is going to be I root 2. This I is going to take out this I right there, and this root 2 is going to take out the root 2's. So this is 1 right here, but the I will take out that I, and the root 2 will take out that root 2. So that's 1. Okay, so here I have 15I root 2 on top. On bottom, I'm going to have 4I times I is 4I squared, and root 2 times root 2 is just plain old 2. Okay, now I squared is -1. Okay, 4 times 2 is 8, so I have 8 times -1 is -8 right there. All right, we never leave the negative in the denominator. It always gets floated out in front. You can put it in the numerator if you want, but float it out in front. And then that's my final answer right there, 15I root 2 all over 8. Don't cancel this 2 that's inside with this 8 that's not inside. They both have to either be innies or both be outies to cancel. So that's the final answer down there at the bottom. All right, so let's solve some of these, you guys. All right, so let's solve this. So here I'm going to go ahead and subtract 25 on both sides, and I get 4x squared equals -48, and I'm going to divide by 4, and I get x squared equals -12. Okay, now before we'd get no solution right here, but now that we know we can do imaginary numbers, we can go ahead and square root both sides, and don't forget your plus or minus, you guys. So square root of -12 is I times the square root of +12. Whoops, I forgot to put my multiplication symbols in there. So I'm going to get, there's a multiply symbol right there and a multiply symbol right there. So 2 2's on the inside brings 1 2 on the outside. All right, let's try another one. You try it with this one right here. Okay? All right, and then unpause it and then see if you got what I got right there. So I got plus or minus 3i root 5. Okay? All right, so complex numbers are in the form of a plus bi or a minus bi or just bi or negative bi. And you can use the exact same operations with adding and subtracting and multiplying we've done already and by combining like terms. So let's try a couple here. All right, so here we go right here. All right, here, when I don't have parentheses right here, let me take away my little thing here. When I don't have parentheses right there, I can just, I'm sorry, when I have just a plus sign in between them, I can just drop the parentheses. Here when I have a minus, I'm going to go ahead and distribute this negative through. So I'm going to get that right there, and then just combine like terms. 8 plus 5 is 13. Negative I plus 4i is plus 3i. Here, the negative 6i and the positive 6i cancels, and I'm left with 7 minus 3 is 4. All right, this one's a little bit different. Remember the conjugate trick in the last lesson? 1 plus 4i, I got to multiply the top and bottom by 1 plus 4i. All right, when I do that, I FOIL out the top because I got a bi times a binomial times a binomial. When I FOIL out the top, I get that mess right there. When I FOIL out the bottom, it's a difference of squares, so it becomes the first one squared minus the second one squared. All right, now remember, I squared is -1, so this plus 20i squared becomes -20. All right, so and then on the bottom right here, 1 squared is 1, 4i squared is 16i squared. Remember, I squared is -1, so this is actually plus 16 right there, and that's where I got the 17, 1 plus 16 right there. And then I did 17 minus 20. Remember, this becomes minus 20 right here. 17 minus 20 is -13 plus 33i all over 17. All right, and then, so plot these numbers in a complex curve, in a complex plane, you guys. Okay, you plot them exactly like you would an XY plane, you guys, except this is my real axes and this is my imaginary axes. And these are like ordered pairs. This is like 4, 2i. This is like -1, 3i, 2, -2i, and then this is like 0, -4i. Okay, so here, let's go ahead and go over 4 up 2i. So over 4 up 2i, there's going to be a point right there. Okay, so there you go. Okay, and then there's -1 plus 3i, and then over 2 minus 2i, and then 0 minus 4i. All right, and if you're in my Algebra 2 class, that would be your homework right there.